I'm Santosh. I'm working as a senior data scientist at Practo. I have around 5 years of experience in data science. And before this, I was a postgraduate from IIIT Hyderabad. So today we are going to discuss about what is data science and what are the related terminologies that you hear often like machine learning, AI, deep learning. And then we are going to dig into what kind of roles do we get in data science like data analyst, data engineer, or data scientist, and what kind of skills do you need to get into each of these roles. So let's start with what is data science. It is nothing but a multidisciplinary field comprising of computers, mathematics, and business insight to get benefit into your organization. So what do we have in computer science is whatever you do in your regular engineering. In mathematics, we have all the machine learning techniques, and in business, we look at what are the insights that you can get from users. All this is possible based on data. So why do we need data science? So there are a couple of examples, like there are human bias that can get into product decisions. So one of my friend was working on a woman apparel startup, and she thought that we have to have more sarees in our product catalog. But when she looked at the data, it said that salwar kameez are the most that are getting sold. So you get human bias very common into product decisions. Data can help you get better decisions there. Human error in repeated tasks. So whenever you see your voter ID cards, whenever there's a manual entry, there are a lot of errors that can creep into your voter IDs. So whenever we can use AI or machine learning, you can reduce that. Achieving scale, like a spam classifier in Gmail. User delight. So whenever a user comes on your platform, instead of just showing what he has done already, if you can show what he would like, that would bring delight to the user. Tackling adversaries, like in the case of fraud or security. Adaptability. Whenever you have new users, how do you show the best content so that they come back to your platform? Unknown environments, like disaster relief or coal mines. You can build robots that can actually navigate the path or find the best path, to make a better coal mine traversal. Or simple laziness or lack of time if you want to get sentiment of a news article or a movie review. Also making sense of massive data at Walmart. I'm going to give an example of what happens at Walmart. So why do we have such an importance of data science now? If you see in the recent last 10 years, we have seen an explosion of data. Thanks to internet, thanks to mobiles, we have around exabytes of data coming in each year. Along with that, we also see a great increase in the compute capacity. The laptops or the desktops that we have today are much powerful than the supercomputers of 1970s. Also, they become cheaper. So with data and with cheaper compute, we are able to make sense of these amounts of massive data. So to give an example of some of the impacts in business, if you take Walmart, Walmart is the biggest retailer in the world with around 20,000 stores across 28 countries. So what happened in 2004 is there was a hurricane in US, and they were able to see that some of the items were not able to be replenished soon enough. And using data, they were able to identify that whenever a hurricane happens, these are the items that are in most demand, and they were able to replenish it faster. And also they were able to find what are the items that need to be placed together in an aisle so that they get sold faster. One of the insights they got from data is that you have to put your child napkins and weave it together so that they get sold. I don't know why. One other use case is Netflix. So how many guys have watched House of Cards? Okay, not many. House of Cards is a season starring Kevin Spacey, directed by David Fincher. When it was being proposed, Netflix was the one who is bidding against like production houses like HBO and ABC. And the reason they're able to do it is because the data said so. The data said this is a great combination to invest in, and they had put their money in this House of Cards season. With this particular season, they were able to get an increase of 1 million users in 3 months' time. So how many have heard about Cambridge Analytica recently and the Facebook data breach? Right? Most of us have heard about it. Amazing insight, right? You can actually make people believe in something without they actually knowing what kind of data is being used. Well, that's a bad use case, but it was amazing that they can actually do it. So one similar use case we have in India is this company called Insight Analytics. What they have done is they look at your Facebook profiles and they look at what kind of things you like. Do you like pani puri, or do you like red t-shirts, or do you watch certain kind of trailers? Based on this data, they were able to target you with trailers of movies like Shadi Mein Zarur Aana, and the producer was able to make good amount of views to his trailer using this kind of analytics. And there are a bunch of other examples that can be impacted. Like in finance, you can have fraud detection, credit risk assessment. In healthcare, you can have disease diagnosis or medical image analysis. Like you can understand the risk of breast cancer by just looking at an X-ray. In CRM, the most famous example is a chatbot, or you can have churn prediction. You can identify which customers are going to churn and thereby give more priority to them. And similarly, in e-commerce, we have recommender systems. So wherever there is data, there can be data science that can be built on top of it. That's the fundamental goal. Now that we have seen why do we need data science, let's look at how do we do data science. The first step in any data science project is to get the data. And how we do it, we'll look at all the user touch points on desktops or mobiles. We collect data into what we call as a data warehouse. You can think of it as a big database. Once we collect the data, then you have business questions. Why are my users not coming onto my platform? Why are they not clicking on these articles? To answer that business question, we extract data only necessary to answer that question. So then you have the data extraction layer. Once you extract data, you have your exploratory analysis, whatever that you do using Python or R. You do the exploratory analysis, you get the insight that, hey, you know, these kind of products are being sold in these kind of regions. So these are the insights that you get when you do exploratory analysis. So once you have the insight, not often that you just use the insight for a product decision, you can also use it for large scale implementation like user recommendations. So you have to build an algorithmic model, which is a machine learning model. We have to build a model, and then we have to create an engineering API around it so that it can be scaled in real time. So this is a typical data science process. And what does a data engineer do? The task of a data engineer is to actually look at all the data points and write code which can actually collect the data points in real time at large scale and put that into data warehouse. That is the task of a data engineer. Data analyst, the task of data analyst is to extract the data, understand the business question there, and extract the insight that can actually impact your product. But data scientist, apart from data engineer, data scientist does what data analyst also do, but he also has to do the machine learning, model building, and product engineering. So that's what the different roles in data science are: data engineer, data analyst, and data scientist. Let's look at what are the skills required for each of these roles. For data engineer, you need to know big data and distributed computing skills like Spark and Hadoop. There are many more which I didn't list here. Then you need to be good at cloud services like AWS, Google Cloud Platform. You should be able to spin up instances or create your own clusters. You should have good coding skills in Java, Linux, and database management skills like SQL, NoSQL. So data engineers usually have to deal with large amounts of data, and Java is a preferred language for that. Collaborative skills. So GitHub, you must be aware of that. It's a collaborative tool where you can actually push your code, and some of your peers will review what you have done if you have missed any edge cases, so that the best code goes into the production. For data analyst, once you have the data in the data warehouse, you should be able to pull the data. So you need to have the database management skills like SQL, NoSQL. You should have coding skills. Python and R are the preferred languages here. It's completely fine if you pick any one of them. Soft skills. So for a data analyst, once you get the insight, you should be able to convince your product manager that this is the right insight and this has to be implemented into your product. So you should have good communication skills. You should be able to ask questions like, why do we need to solve this? What does the user benefit from this analysis? So visualization libraries. These are the libraries which will be useful for doing exploratory analysis. For Python, it is matplotlib. For R, it is ggplot. So if you are working with any of the coding languages, you need to know any one of the visualization libraries. And the dashboards. If you are not familiar with the languages, you can use dashboards instead. What dashboards do is they directly connect to your databases, and you can just use your SQL queries and produce visualizations. For data scientists, as I mentioned, you need to have the data analyst skills. Along with that, you should have AI skills as well. We haven't discussed what is AI. I'm going to discuss it later. It's good to have some domain skills, like what do you mean by domain? There are computer vision, natural language processing, speech and robotics. So AI was able to have some progress in these domains in the last 50 years. By computer vision, I mean whatever images that we see, the computers are able to comprehend what is in the image and what is happening, what kind of objects are there. That everything is related in computer vision field, and now deep learning is taking away the entire computer vision and making it machine learning applications on top of it. Natural language processing, whatever you see in your chatbots, whatever you type, how do you comprehend what is the text that is coming in, what is the user asking for? That comes under natural language processing. Speech, whatever we are talking right now, how do you understand what the user is talking? And robotics. So, and the engineering skills is also required for a data scientist to, able to productionize his machine learning model. If you have a machine learning model, it's as good as useless unless you productionize it. So you should know how to make a real-time API around it, and how do you make it useful for a large number of requests. Again, the collaborative skills are required for data scientists. So let's talk about AI. AI, before we talk about artificial intelligence, let's understand what is intelligence. Intelligence is nothing but whatever you interact with the environment. Think of it as a child. Like if a child is walking into a kitchen and he touches a hot vessel, then the environment says that, hey, this is going to hurt you, and the child would understand it and doesn't do the same thing when he goes to the kitchen again. That's the same thing which happens with computers. Computers interact with the environment, saying that, hey, tomorrow the Apple stock price is going to fall down, and the environment says that, hey, you're wrong. The agent learns it and makes a better prediction next time. So what is a human expert AI? Human expert is nothing but there's a human who is sitting between the environment and the agent. He tells the exact rules which you have to follow. To give an example, let's look at simple rain prediction system. A human says that, hey, if the humidity is greater than 80, you should predict that it is going to rain, or else it is not going to rain. This is a simple rule-based system that human has used its knowledge to give to the AI, and the AI just predicts it as the rules are. One such example is Mycene. Mycene is a Stanford rule-based engine which is used to predict what are the antibiotics you have to use for any illness that you get. It's like a simple rule-based engine. But then what happened is we have seen the internet, we have seen the data that is coming in. Now we are not able to build as many rules as we were used to before. We have to use this data. And now came the machine learning. To extract these rules, we have built algorithms. With large amount of data points, we are able to build better rules. So now we have data points instead of human experts, and we have machine learning algorithms that are building models on top of it. Same example, the rain prediction classifier. Now we look at a machine learning perspective. Now we have 3 data samples there: humidity, temperature, and whether it's going to rain or not. These 3 data points, we give it a machine learning algorithm instead of a human expert. This machine learning algorithm has come up with these rules saying that if the humidity is greater than 70, predict that there is going to be rain. This is a rule that we are able to come up from the data without a human expert. This is helpful when humans cannot actually predict in many cases, like credit card fraud detection. Machine learning models are useful there. So what is machine learning? To give a brief overview, it is a subfield of AI. It is nothing different from AI. AI is comprising of expert and machine learning. So machine learning is the automatic extraction of rules from data. And it is built using algorithms which are borrowed from statistics and optimization techniques. It's nothing new, as in machine learning has not come up from scratch. It has started from statistics, it extended the statistics. What are the types of machine learning? Supervised, unsupervised, and reinforcement. I'm not going to get into that. So now we have understood machine learning. What is deep learning then? Everyone is talking about that. We have seen many news articles about it. It's nothing but it's a subfield of machine learning again. So it's quite of crazy, but there is one algorithm in machine learning called neural networks, and this was able to extract many more patterns than the traditional machine learning algorithms can. And that's why deep learning is successful, nothing more than that. It's just one form of machine learning algorithm. Like a decision tree, neural networks is one other algorithm. So what does a neural network look like? these are what we call as neurons. The circles are called as neurons, and these are the connections between neurons. Neurons is a concept borrowed from human neurons. I'm going to show you how it is. So for the same example like humidity and temperature, we now have a layer called as a hidden layer. This is the input layer where we get the values of humidity, temperature, and we get a prediction called rain. What we have here is hidden layers, and because of these hidden layers, we're able to extract many more patterns of input features. I'm going to show you an example of how deep these hidden layers can be. You can have multiple hidden layers like this. So as I was mentioning, it was borrowed from human neuron. A human neuron looks like this. This is the nucleus of neuron, and these are the dendrites. So what happens in human nucleus is, whenever there is an input coming from dendrite, there is an electric impulse, and this gets excited. When it gets excited, it passes on that information through axon and passes on to other neurons. So that's what a neural network in human brain is. We are replicating the same thing here. This is a neuron. It gets an excitement from one of the input, and it passes on to other neurons. So to give you an example of how complex neural networks can be, the deep learning, each of these blocks you are seeing is a layer like this, and there are many more. Like in each layer you have multiple such neurons, and this is a model called Inception V3 by Google, and this is just to give an example of how complex it can get. The deep learning, what we call deep learning is nothing but, if it's a deeper architecture, it's called as a deep learning. This is what we call as a neural network. If you have more hidden layers, we call it deep learning. So just to summarize, artificial intelligence was coined in 1955 by John McCarthy, and there were simple rule-based engines back then. And later we saw a lot of data coming in, so we made the rules to be automated from data. That's what we call as machine learning. After 2010, we saw a massive amount of data using, the help of mobiles and internet. And then also we got GPUs getting cheaper. So we got deep learning working. So deep learning algorithms that you're seeing today, the convolutional neural networks or LSTMs, are invented in 1989. If you imagine, they were invented so long ago, but they are being used now. The reason because we didn't have the data and we didn't have the compute power. So only in the recent past, in the recent 5-6 years, we are seeing a massive amount of use cases just because we are able to use the data and we are able to have the compute power. This is a very simple example where you don't need deep learning. For this particular use case, you can just use a machine learning algorithm. But there are many use cases like, can you identify patterns from an image? Can you say if there is a cat or if there is a dog? The simple machine learning algorithms are not able to do that. That's where your deep learning algorithm comes into picture. So whenever you have more complex mind, if you can't just use a simple rule, it's better to use a deep learning algorithm. So to use deep learning algorithms, first you need to try machine learning. It's never the case that you have to go with deep learning all the time. First you need to try machine learning. If you're not able to get good success, if you have good amount of data, it's better to start using deep learning then. Because what deep learning is says that it's just an extrapolation of machine learning. Say that I can do much more pattern matching than machine learning can. And for that I need more data. So oftentimes if you have more data, you're good to go. But there are new techniques coming in like transfer learning, where even with little amounts of data, you can actually use deep learning. So yeah, even before we go into cognitive, it's just about finding difficult patterns. Like what you're talking about, handwritten recognition here is, if you have a simple letter A, B, C written by a human, can machine identify what are the characters there? So for that, there were many techniques using traditional machine learning, but there are so many variations in which a human can write in a character, and that cannot be captured by machine learning. So what deep learning does is that it just looks by pixels, and it rolls over the entire image, and it was able to have invariant representations of image. By invariant I mean, if you write A like this or if you write A like this, it is able to still identify that it is an A. So that's where deep learning is coming into the picture. So whenever you have complex patterns to mind, deep learning is useful there. Yeah. So how does the future hold in data science? So today we have around 20 billion connected devices on the planet. It is expected that we will get 50 billion devices by 2022. Only with 20 billions we are able to get this much of data. Imagine what we can do with 50 billion devices. In India, we have around 616 million unique mobile users, which is expected to go up to 951 million by 2020. And by 2018, this year alone, US would see a shortage of 2 lakh data analytical skills, people with data analytical skills. And I brought some insights from Indeed.com. You can also go and check it out. This says, what is the job postings in data science field? It can be data analyst or data engineer or data science together combined. So in 2014, it was around 0.03% of all the jobs in the Indeed.com. 0.03 are from data science in 2014. That has risen up to 0.15. See, we have seen a 5x growth in what, 3 years. But in the job seekers, I mean, number of people who are willing to take the job, we have seen a growth of 0.02 to 0.07. It's like 3-4x growth in the same span. So what does it take to actually, now you are in a different field, maybe you are in software engineering, or maybe you are right now pursuing your undergraduate. How do you transition into data science successfully? The first thing, very important, is to find the right company. What do I mean by right company? Is the one which has data. There is no value if you join a company which has no efforts in collecting the data. Choosing the right tool for the job, as one of the questions was, do we always use deep learning? You should not use deep learning always. It's sometimes better to even go with a rule-based engine. It's sometimes better to go with a machine learning-based system. So it depends on the problem that you're solving. Don't always use deep learning or the most fancy algorithm that you see. Stay curious. What happens in deep learning in this community of data science is that you have to ask questions to understand the business. If you don't ask questions, you would never understand what's happening. So you have to keep asking questions for your manager or for your business analyst. What is it that they're doing? What kind of results they are expecting? Why it didn't happen this way? So you should be asking more questions. Being proactive. So whenever you see a use case of data science in your organization, try to think what you can do. Try to just go there. I've learned this thing. Maybe I can help you there. This will give you a better perspective of what the business looks like. Be data driven, obviously. Continuous learning. So I have a very good video which I didn't add here, but how many of you follow Jay Shetty on Facebook? Great. So he recently posted a video where he says that your education doesn't stop with your degree. Instead, he says your education begins after you finish your graduation. I felt like that's wonderful advice, because wherever you go after your degree, you have to learn new skills. It doesn't end with data science. Tomorrow there may be something new. You have to keep learning new skills, otherwise you will perish. Of course, you have to follow people on Twitter. That's the only way you can know what is happening in the data science community. You have to contribute to open source. So these are some of the techniques. I would suggest, if you want to get job offers, these are the 4 techniques I would suggest you to look for, where you have to contribute to open source projects. People will look how good a coder you are by looking at how many open source contributions you have done. Acadgild is a website which hosts data science competitions. This should be the only website you should be looking for the next 6 to 8 months. You should often visit it, do competitions, try as much as possible, try solving problems there. That will help you understand data science better. Write blogs, whatever you have learned, no matter how simple it is, just write a blog, even if it is 100 words or 200 words. This will help you, stay above the rest of the crowd who are applying for data science jobs. And attend conferences. You will get to know good contacts and maybe job offers there as well. So how to learn? As I was mentioning, it is a multidisciplinary field. In mathematics, we have subjects like linear algebra, probability and statistics, optimization techniques, and machine learning. In coding, we have obviously the languages Python, R. Any one of them is fine. Engineering skills like how do you make a better APIs, GitHub, and big data skills. In business side, I would suggest you to look at the book called Lean Analytics. Lean Analytics is a book which understands, what are the metrics to understand if you want to make your business better.
Acadgild. Average is dead.